Welcome, everybody. My name is Catherine Lawrence. I work for the Science Gateway's Community Institute, and I want to thank you all for joining us for this repeat of last month's technically interrupted webinar about the Bridges platform. So we'll be talking about that momentarily, but first I wanted to do a little bit of background housekeeping to let you know what's in store for you. We have muted your audio, and please also turn off your video if you're just joining us. You can see what the icons look like and should look like at the side of your screen. These are near the bottom right side of the control panel on BlueJeans. You're welcome to also submit questions at any time using chat. If it looks like an urgent question, I'll be interrupting our presenter and asking the question for you, but otherwise we'll be holding most questions till the end. Also, when you submit in chat, do be careful not to accidentally click the leave button, which is right above the chat button, and if you're a little bit off, you may end up disconnecting yourself, which I know from personal experience. The recording of this and the slides will be put on our website at sciencegateways.org in the webinar archive, so I do hope that you'll let other colleagues know about this as a resource. And one also little pitch I just want to mention is that Gateways 2018 is coming up at the end of September, and we hope that you'll register. Registration closes on September 7th. So I want to tell you a little bit about Science Gateway's Community Institute and who we are, the folks who bring this to you. And oops, whoa, here we go. The Science Gateway's Community Institute is funded by the National Science Foundation to provide resources and services to the community of people who develop and use science gateways, and that's in particular sharing experiences, technologies, and practices. So this webinar series is part of that sharing of information process. And then we have 5 service areas that bring you a variety of services and experiences. The first is the incubator, which does exactly what it suggests. It's just like a startup incubator, and we provide various kinds of specialized services and advice through consulting to projects that want to know more about particular areas of best practices such as usability or cybersecurity and other kinds of technology questions. Extended developer support provides similar consulting services, but a hands-on direct custom development for a project. So you can apply for both of those custom services, consulting services on our website, and then someone will follow up with you and learn what you need in the way of support. Our Scientific Software Collaborative has developed a gateway catalog that you can either post your gateway on there, or software that is a component for gateways. It's a great way for other people to find you, so that is also linked from our website. And we also have an affiliates program for those who are interested in supporting their software for those who are part of this community. Community engagement and exchange is the area of the Institute that brings you this webinar series, as well as our conference, and also maintains our website. So if you have some kind of event coming up or interesting resource that you'd like us to post, just let us know through help@sciencegateways.org. And finally, our workforce development area is there to build the capabilities of students and young professionals interested in working in the Science Gateways area. That includes internships as well as special workshops and programs throughout the summer. So with that, I just want to put in one short plead that if you have a chance after this webinar to just take less than 30 seconds to give us your feedback about how this was useful to you, that would be very appreciated. It's how we share our impact with the National Science Foundation. It also is how we get input from you about future topics. So there is an open-ended answer that you can also put in there, whether you would like to hear future topics. So I'll be posting this URL on our website in the middle of our presentation at some point. So with that, I'm going to stop sharing my screen and let our presenter get his slides up and running. So you can go ahead and do that. And so I would like to say I'm very pleased to introduce our presenter for this month from the Pittsburgh Supercomputing Center to talk about bridges. Our presenter is, here we go, Sergiu Sanielevici. He
Excellent.
is, oh, awesome, great, I'm glad I got that right. He's the Director of User Support for Scientific Applications there at Pittsburgh Supercomputer Center, and he is going to talk about all that you might want to know about hosting science gateways on bridges. So with that, go for it. And
thank you very much,
I see
Catherine.
your slides, but they're not in presentation mode yet, just so you know.
Not yet.
Yes.
Thank you very much, Catherine, especially for the sensational pronunciation of my name.
Yay!
It's the best I've heard in a long time. So, okay. Let me see if I can enter presentation mode. Yep. There it is.
Yes.
So I guess, this is an attempt to redo an attempt by Nick Nystrom, the PI of Bridges, to give this talk a couple weeks ago. I don't know if any of you saw any of his slides, but I'm just going to pretend like that one never happened, and I'm just going to do the thing from the beginning. So one thing about Bridges is that we are now, of course, a proud partner of the Science Gateway Institute. So, we, are happy to partner with all the areas of the Institute that Catherine just discussed. And basically, we would just like to acquaint the community with the resources or the way that Bridges can be useful to current and especially future gateways, and so that we enhance the partnership with the SGCI. So here's the outline of the talk. We do have quite a few gateways already using the Bridges system, and we get a little bit into how that's done, and then into basically strategizing or just how we will work together in future to get additional gateways onto to take advantage of the Bridges system. So the way, and I'll get into that shortly, from the beginning of designing the Bridges system in kind of the 2015 or so area, we did intend the system to be specifically, useful for things that gateways are designed for, which is basically ease of use, flexibility, and essentially lowering the barrier to end users in using HPC and advanced data processing system, advanced data analytic systems. The way we've been thinking of gateways is HPC software as a service. Now, of course, it's also big data as a service, AI as a service, but we do think of gateways as a way to provide easy and flexible access to a whole host of advanced computing resources. And again, we've always designed the system from the beginning as hospitable to VMs, databases, and distributed services. So as I said, there's quite a few gateways that already use Bridges, and this is not going to be an exhaustive list by any means, but just to illustrate kind of the range of course, you guys are familiar with the fact that the concept of gateways encompasses a whole host of different ways of doing things, and correspondingly on the part of the service provider, there's many models for supporting them. And so we're just going to try to kind of illustrate some of those. So one example is Galaxy, which I think many of you know as a very powerful and flexible platform to essentially a framework for various disciplines to, or scientists in various disciplines to organize their work. It has been traditionally and still mostly is focused on bioinformatics applications, but it has features that are adopted by other communities as well. So what's interesting here about the specific bioinformatics instances that we support on Bridges is that on one hand, we support the so-called Galaxy main service, which is hosted at TAC, but when that detects certain workflows, specifically large memory assemblies, such as the Trinity RNA or transcriptomics assembly jobs, those are automatically routed to Bridges because Bridges has its famous large memory nodes. So that's one way in which Bridges supports remote gateway, where the service is remote, but depending on things that are detected in the workflow, the framework sends them to Bridges. There's also a local Galaxy instance at PSC for the benefit of users, bioinformatics users at PSC or on Bridges itself, and that is a local instance which is based on Docker. Since we operate it, we use Docker. Docker, of course, has known security issues, but since the instance that we run, that our systems administrators run, we accept Docker for that. The Neuroscience Gateway, I don't know if Amit is on, but that's one instance of a remote gateway, a very popular gateway that, among other resources, can use Bridges. So this is a different kind of gateway architecture that we do support because the Amit and his team did the work of actually interfacing to Bridges. So we get jobs from the Neuroscience Gateway. Another one, by the way, that's not called out here in the slides, but and probably the gateway that sends the most jobs to Bridges is Sigrid, which again, the instance is remote, so we don't host the gateway on Bridges, but we take jobs via community account. One gateway that maybe other folks don't know so much about is an actual Center of Excellence project that is in which PSC participates along with folks at the University of Pittsburgh and Carnegie Mellon University. The co-PI of that is actually Nick. So this is an interesting thing. It's actually the collaborators on the Carnegie Mellon side are actually philosophers, because there's a long-standing, of course, effort to distinguish causality from correlation, and there's Bayesian software that has been developed for that purpose. But prior to the ability to access high-performance computing, that was very limited in the number of variables that it could handle. So a couple of years ago, there was this NIH award that enabled the community to use high-performance computing resources on Bridges, specifically in order to support this improved software that they use to identify a number of hypotheses that stand a chance of being causal. So in studying things like fMRI data, the algorithm doesn't tell you that, this is the only possible causal relationship between your variables, but it gives you a number of hypotheses, maybe 10, 20, something like that, that do stand a good chance of being causal, and then you can design experiments to explore those further. But the point of going to bridges is that now they're able to go up to 1 million nodes and 1 million edges, which is a lot more than they were able to do before. So maybe of interest here is the architecture that is used in order to use bridges for this gateway. It's a gateway because there are many stakeholders, both researchers and educators who use it, and who, of course, have not learned things that you need in order to actually run the jobs on a high-performance computing system. What's interesting is generally the way that we support gateways actually hosted on bridges itself is that we use a web node and a VM, Apache Tomcat that lives in a virtual in a VM, and we also have a database node, and this is essentially also the way that the local Galaxy instance is supported. That's typically the way gateways are supported on bridges, by dedicating a VM and dedicating a database node in another VM. So one VM for the web service and one VM for the database. And then the applications that this is used for use the cancer research. I forget. I'm terrible with acronyms, but it's a big cancer genome. I think it's the Cancer Genome Atlas, and fMRI. This is a file system that's actually hosted by the biomedical collaborators, but then they have access via the network, that the machine network that we'll get into in a moment, to the various kinds of nodes that are available on bridges, which are which again we'll get to the architecture of bridges shortly. So all of these in various permutations are used for the back-end work of this project. Recent addition that is also interesting to talk about is that's a recent award of the Brain Image Library, where on bridges there's going to be this large collection and growing collection of confocal fluorescent microscopy data, and this is being integrated with bridges to support advanced analytics and development of AI and machine learning techniques. And here, like maybe on behalf of ECSS, Exceed ECSS, which I'm a part of, we do have the ECSS Symposium series, and I think the most recent talk there was, in fact, about this project by Derek Simmel. So, for folks interested, we can certainly share. You can discover the ECSS Symposium webpage in the Exceed space, and there you will see a recording, a video of talk about this. But what's interesting here is that we actually view community dataset hosting as, in a way, structurally similar to science gateways, and we do hope that a lot of folks who bring community datasets to bridges will also want to have the folks accessing them do operations on them in terms of, discovering or generating derived products and doing analysis there, So that then is the natural application for a science gateway. So yeah, Bridges does support gateways, and in a way that was built into the architecture that we set out to solve when we proposed the system, when we designed the system. So these are all things that are, I think, naturally interesting to be made available to the community via gateways, and specifically the fact that Bridges from the start was targeted at non-traditional users, and that enabling multidisciplinary applications, coupling them in various ways, and at leveraging large memory, GPUs, and high band. So that was kind of the way that Bridges was designed from the start. This is something that, like in the 2014 timeframe, maybe was not as common, but it's certainly, everybody talks about it now. So it's really a system for converging high-performance computing, high-performance data analytics, and AI. So it's certainly very topical now for what people are doing. So yeah, the goal of Bridges, by whatever means, is to make advanced computing accessible to all research communities, and that is both in terms of the architecture, the hardware, the fact that it has both CPUs and GPUs, and also in terms of the software deployment. That again is not the way, is beyond the way that just traditional HPC, but we do aim to provide a wide variety of software frameworks that are used by many communities, not users of traditional supercomputers. If you wonder about these little pictures here, these were some of the very early 2016 vintage applications of Bridges. The rhinos are the whole genome assembly of the Sumatran rhino, which is endangered, so we need to understand as much as possible about them. And then this here is a AI driven machine or human language translation application, which starts from analyzing the waveforms in one language and applying that to things like saying Sergiu, Sanielevici. So just a little bit about the architecture of Bridges that makes this possible. Are you guys still with me?
We are here listening. Don't worry.
I just remembered about what happened last time. So
we're here. We're here. There's no problems with BlueJeans today.
All right. So yeah. So the conceptual architecture of Bridges, again, aimed at flexibility. So in orange are these nodes, and specifically database nodes and data transfer nodes and web server nodes, which are specifically important to interfacing with or hosting science gateways, whether they be remote or hosted on the system itself. Really, the key here is the Intel OmniPath architecture fabric that hooks all these elements together. We have a parallel file system, we have management nodes, and then we have the business end, which is 4 12 terabyte RAM nodes. So you can basically, cram a lot of stuff into just, a single process in principle could drop on 12 terabytes of RAM. Then we have a larger number of 3 terabyte shared memory nodes. So from the allocations point of view, these two are known as the Bridges large memory resource, which one can apply for. And that's denominated in terabyte hours. So the service units, the exceed service units on those are actually terabyte hours. And then we have the what we call the regular shared memory nodes. These are 800 nodes, each of which has 128 gigabytes of RAM if you were to use all the 28 cores on a node together. 48 of these nodes are actually endowed with GPUs, and those are allocated, the GPU nodes are allocated separately. That's what we call the Bridges GPU resource, which is denominated in where the service units are GPU hours, and the rest of the regular shared memory nodes are known as the Bridges RM resource, and those are allocated in just plain old core hours.
We have a quick question from a listener,
Yes?
which is, are the orange nodes VMs?
The orange nodes, we can place VMs on them, yes. I mean, these are just the nodes, but they can host VMs.
Okay.
They typically do host. Now, this isn't working out too well in this version of the slides. This is supposed to be an illustration of what you need for an AI workflow. It doesn't show up, to me, it doesn't make much sense other than calling out the various elements that would go into a typical AI workflow. So I'm just going to go on. This is for like total hardware nerds. We're not going to dwell on this. The specs of the various nodes. Flops, again, maybe not that interesting, except to, let you look at the numbers here for a while. Maybe that's of interest at the moment, and I think that's the moving target, and it's being increased, is that the parallel file system called Pylon, which is another called out in allocations as a different resource again, has 10 petabytes available. Element of interest, I mentioned the thing holding the whole thing together is the Intel OmniPath, and this was the actual first production deployment of OmniPath, and we actually architected it. We designed the fabric to suit the way we wanted Bridges to work. It was not an out-of-the-box deployment. It's working out pretty well. It's okay. We get a lot of questions about OPA versus InfiniBand, things like that. It's a moving thing, but we have a lot of users on Bridges, and by and large, nothing is perfect, but it's working okay. It's doing what we need it to do. So we do have GPUs. We have two flavors of GPUs at the moment. The first batch was the K80s node, and these days we mostly use those for things like VAST, GROMAX, so enhancing NAMD, so kind of traditional applications that have been enhanced to use GPUs. That's mainly what we try to use the K80 nodes for. We do have these P100 nodes, and they're the AI workflows that we get, and machine learning, we tend to steer towards the P100 nodes. There may be more of these things in the future, and so we are in the process of enhancing the AI sector, and hopefully that will come to fruition by end of the year. Stay tuned for that. Another feature that we promote strongly is interactivity, and there's various ways of doing that. You can actually, there's a partition basically of a sector of nodes, both in the in the GPU and in the large memory sector, that is set aside for interactive access. So hopefully there, if you go to that partition, you will quickly get a shell. We can also do, of course, reservations, and there are allocations that actually, by means of VM or whatever, actually say that they want to use, dedicated resources for the duration of the allocation. So that can also be arranged. So you can use your service units by saying, yeah, the whole year I'm going to use, a specific set of nodes, and if your allocation supports that, if you're able to convince the review committee that that's how it should work, then we welcome that. We host dedicated database nodes, as I said, so you can have, you can use your allocation, or a gateway can use their gateway allocation for their users to just make dedicated database nodes available on a persistent basis for months or for the whole duration of the allocation. And we support a whole variety of flavors of things. If we don't have what you want, then we can work with you to install that. And again, web server nodes can also be dedicated for the duration of, say, a gateway allocation or a user's allocation. We, like the whole, all of us in the community are learning about virtualization and containers. We've always done it, but we learned better and, more secure ways of doing it. For management, we do use OpenStack. To date, actually, the demand has been for persistent database and web service installations, including for the gateways that I mentioned before that already use bridges. We do support containers. The demand for Hadoop especially, but has kind of gone down over the years. It's not so popular anymore, but we do support it. Hadoop and Spark are, to date, have mainly been used for classroom applications for education and training. And of course, like everybody else, we do focus on Singularity these days. We support what we call high productivity programming languages. That's always been supported. Again, if just recently there was a ticket to install SAS, and we're doing that. So if there's, especially if it's already supported by a user's license, so we don't have to spend additional money on licenses, then we will be happy to accommodate requests for additional languages and additional frameworks. We don't promise that we'll do it, but we'll look into it. One thing we do support, and we work with Ohio State to support, is on-demand. If you were at the recent PERC conference that we had the honor of hosting in Pittsburgh 2 weeks ago, there were talks about on-demand there. So we deploy that, and we have certain apps that we've already installed there. Specifically, given the demand, we run Jupyter. There's an app like a pre-wired app to run Jupyter and Jupyter Notebooks, Jupyter Hub through on-demand without logging into bridges via traditional interface. Again, one thing that things like Spark and related database applications may find interesting is the large memory nodes, because that would allow you to cram a whole lot of data into memory without having to do I/O. So there's been some instances of that, and that could be, for these things, the large memory nodes might turn out to be interesting. We support a whole range of deep learning frameworks on the GPU nodes specifically. Again, if we don't have it, if you have something new and exciting, then we can look into helping to deploy those. Data collections, they're interested in those, specifically in connection with doing some interesting analytic work on them. There's some that are already hosted here on Bridges. And again, we want to work with the community, and I think there's a lot more opportunity on Bridges that has not yet been exploited. So working together on additional gateways, that's really the main pitch here, is that we think we do have an interesting opportunity to offer here in terms of the resources available. We want to power science gateways with these converged HPC and data analytic resources. One strategic direction that we do have is big data as a service. So a lot of people that we find in Exceed and elsewhere have heard the buzzword. You've got to do big data, even in traditional fields such as physics and material science and chemistry. Combine your simulation with analyzing, data that have already been accumulated, and maybe, be smarter about the kind of simulations you run, things like that. Everybody has heard it. There's some pressure in research to actually say that you do it or find intelligent ways of doing it. So we're interested in supporting that and helping people do that. The challenges that we hope that our partnership with the Science Gateways Institute is going to help us address is to reach additional developers and to promote web science sites through science gateways that may already exist. One recent instance, maybe the newest gateways that is using Bridges, is GISandbox. Again, that was the talk at PERC about that, but that's led by Eric Shook, but it involves I think folks at SDSC and at NCAR, and there's a lot of synergy with the CSS program. But in terms of architecture, this is an interesting architecture that was developed for that, and also prior to that for a specific Exceed ECSS project that Eric was involved with. But what's interesting here is that it uses Jupyter notebooks, and it uses Jetstream, and then it has a way of launching jobs onto Bridges. So the actual gateway is mainly hosted via Jupyter Notebook on Jetstream at Indiana, but then it goes and launches, which is another, Jetstream, of course, is another SGCI partner, but then it goes and launches jobs onto Bridges when that is required. So just an illustration of the fact that we're open for business and want to work with additional gateways. So in summary, well, you guys probably know that there's no charge if you come in through things like Exceed for open research. But the platform, Bridges, is specifically there to support converged HPC, AI, big data using familiar, widely used programming languages and models, and it's open for specifically targeted at supporting science gateways. So we hope that today will help in getting out the word. So that's it.
Thanks so much, Sergiu. I think we'll open the floor to questions. We're a small enough group, too, that if someone wants to just unmute themselves and pipe up with a question, that's also welcome. While we're waiting, I'll also put up our final slide just to let you know about what's coming in the future, and let you know also how to give us feedback on this and suggest other webinar topics. So I'm going to share my screen momentarily, unless there's anything else that, well, let's see. I guess I could stop sharing if you have something that someone wants you to point to. So I'll just get that going right now. So any questions coming from our
I see one on the on the chat, which is from Chun Han. Yes, we do. I will have to dig them up, but I'll share them with this because I think we had a very early talk about that back in 2016, and more recently, I believe this year, we actually gave an Exceed outreach presentation for University of Puerto Rico, I believe Mayagüez, and that led to canning that presentation in form of well, I'm not sure if it's a tutorial per se, but it kind of is. So we have that about bridges, and then of course there's the monthly Exceed workshop series, which is a what we call a distributed classroom that typically gets 20 or so satellite sites, and those are hosted on Bridges on topics such as big data, OpenMP, MPI, things like that. And those are typically available also as YouTube videos. Okay, published papers. Published papers, yes. Well, I just mentioned this GISandbox talk that was given at PERC 18, and that's available in the PERC 18 proceedings, which you can find by just going to the PERC 18 website. There's a link to the ACNDL proceedings of that. There may be others. I mean, other gateways, when they talk about their things, may or may, so there's obviously papers about the Neuroscience Gateway. There's lots of papers about Galaxy. Not totally sure to what extent, Gateway talks actually reference the service providers they use, but yeah.
I'm throwing these into the chat, so we'll have a record of it too. So, yeah, there's a question. Mona's gonna unmute to ask you a question, I believe, and then after that,
I was expecting Mona to ask a question.
I do too. Thank you, Mona.
Hi, can you hear me? Okay.
You're a little faint. You're a little faint, but
okay.
I can hear you.
Okay. I was wondering if you could talk a little bit about the web nodes. In particular, I'm wondering if a gateway wants to host their gateway somewhere. I assume a web node can provide that kind of hosting without having to set up a VM, or how does that work?
I think the web node, so maybe that's a qualifier to my orange node thing. I think maybe in that diagram, the web node is for the use of the system itself. So I don't know. I don't think it's actually. So I think if you want to host say, a gateway portal on bridges, I think you would actually go to a regular, we would set up a VM for you on a regular memory node.
Okay.
So I think that would be, and I think there would be some charge for the cores you use for that would go into your gateway allocation. So I think, yeah, the orange nodes, I think those are for connectivity for the system itself, I think.
Okay.
But yeah, as far as I know, like even the Galaxy or things like that, the VMs they use for their users, those are hosted in regular memory now.
Okay. And then a question about the policy about the community account usage on the VM. I don't know if this is a little too specific, but if you go through Exceed, you get a community account, and how would
That's not in there.
Sorry?
Yeah, I don't think that goes. I don't think that would go into the VM. I mean,
Okay.
so for instance, Sudhakar for GISandbox or Amit, for the Neuroscience Gateway, they just have regular community accounts like PI Sudhakar has 5 or 6 regular users, but then he also has I think it's called GCommuni, which is a community account. So that's not part of the VM. And Sudhakar does not use a VM for his gateway, for example. So that's not. So you would only get a VM if you have like specific database that, for instance, you want to host persistently as part of your gateway, or if you want Bridges itself to host like an Apache, service in order to handle your gateway. If the gateway doesn't handle them at their own.
Okay, thank you.
Sure.
And there was a follow-up question, which I think might be related to this. Ishwar asked if there's a cost associated with its use, and I know you mentioned that it's free as part of. I mean, this is allocated through Exceed, I guess, but are there costs
associated with what?
With the use of bridges, I'm assuming is what Ishwar is asking. If Ishwar, if you want to unmute yourself, you're welcome to clarify.
Yeah, I mean, if you come in through Exceed, there is no cost. They're also discretionary. So there's, as usual, as part of the NSF cooperative agreement, which, by the way, and maybe I think maybe there's something in there in the beginning, but Bridges, I should say, is NSF, what we call Track 2 resource. It's operated as part of a cooperative agreement with NSF, and so 90% of it is allocated via Exceed. 10% is discretionary at the PI's discretion. The PI being Nick Nystrom. So if there's a compelling use case, not to go through Exceed, we can discuss that, or for commercial purposes or things like that. But
thanks.
But otherwise, we're governed by Exceed policies.
So just to add on to that, if a researcher had an application that they deployed and sent jobs over, and there's a whole community of users running those applications, who's bearing the cost for the compute?
The gateway would be. So the way Science Gateways typically Exceed, at least the way they use Exceed, is that the creator of the gateway, or the people who operate the gateway, obtain for themselves a grant, an allocation on an Exceed allocation, which then specifies the various resources they want to use, and bridges could be among those resources. So they go through the exceed allocations process, and then the users, the end users that use that gateway, benefit from that gateway's allocation. So
Got it.
it's a process whereby the administrator, the creator, the operator of the gateway deals with exceed, and that's how they obtain the allocation, which then the end users are free to use, subject to the policies of the gateway.
Okay.
And it looks like Colton Granger posted a link. I assume that's in reference to finding out about allocations in general, not an answer to Mona's question, which had to do with.
Like. Yeah, that's what it looks like.
Yeah, and then so Mona had a question about the bridges on demand use and who to talk to about that.
I'll introduce you, Mona.
That sounds like a good plan. And also, actually, maybe that's something we could, because when we post this on our website with the archive of the video in your slides, perhaps we could also put that link in our archive too.
I mean, the answer to Mona's question is more like a person.
Right. Okay.
I mean, okay. Okay. What I should say, and maybe somebody can quickly discover it, but we do have all answers are in the Bridges users guide. I mean, I think that would be. I'll if you can't Google it, then I'll send you guys the link right after the talk. And but Googling it should find it. You know, you can just say Bridges users guide, also abbreviated as BUG.
Oh, so, that's cute.
Yeah, I mean, if you think about it, that's what it is.
Oh, yeah. Gosh.
It is.
Colton is very fast. I'm impressed.
In
yes.
principle, everything is there. If there's something you want to know that's not in there, then you can send email to bridges@psc.edu, which is our helpline, and until we replace it by something like help at, but whatever. So then, you know, if you have a question that's not in there, we do want to know.
That's great. That's good to know. Seems like a good enough place to be where you go for help instead of just saying help, I suppose.
Yeah, there's some suggestions that, you know, it might be more intuitive to do that, but right now it's bridges@psc.edu. So all things bridges.
We'll definitely make sure we include all of these resources mentioned that have been posted in chat and that you've mentioned on our archive. We have a couple more minutes if there's anybody who has any further questions. We're totally open for additional questions.
I just want to ask Mona, in the chat, you use a sad face when you say, okay, thanks, Sergiu. Is that?
No, it's sideways the other way.
Yeah. So I want to know, Mona, are you actually, is that not a good answer that I'll introduce you to the on-demand people?
No, Catherine's right. It's actually a smiley face, but in the other direction.
Okay, but you don't mean it.
No, it's a smiley face that, you know, the eyes are to the right, to the right of the smile.
Okay. Good. Yeah. I just wanted to make sure.
It's because she's on the West Coast. Everything's backwards there, don't you know?
Yeah, we're good. Thanks, Sergio.
Okay, good. Thank you.
Well, I think what I'll do, I'll thank you as well, Sergiu, for your thorough covering of all this and answering questions and so forth. And then while folks think about if they have any additional questions to ask you, I'm gonna just mention one last plea to give your feedback about this, as well as provide any comments about other topics that would be useful for you to have us feature in this webinar. There's a space for that in this evaluation link that you can see on the slides, and it's also in our I'll just post it again right now in chat. And then our next webinar will be on September 12th, just in time for our conference. This is actually a recap of last year's, one of our keynotes at the Gateway's 2017 conference, presented by Elisa Arbach, who's here at the University of Michigan. And one of the things that she has specialized in is how can researchers better convey what it is that they do to their communities. So she gave a keynote talk about recognizing who your audience is and how to tailor your presentation to explain well to that audience. And so she'll be doing a webinar version of that keynote on the 12th. So we hope that you'll enjoy it and join us for that. It's a slightly different time. It's just 1 hour later than we usually start because of her availability. So mark your calendars for joining us for that, and we will be recording that one as well. And of course, we have opportunities for students, both particularly during the summer, but also at the conference coming up. So we want to make sure that you know about all of that. And I see another question has come in from Colton. He says, what's an example research request that you found particularly compelling?
And I just typed the answer.
That's you. Okay.
Yeah, I mean, there's not one, but I do find it very interesting that in the past couple of months, there's many of these kind of multi-method, multidisciplinary things that come through, like where, you know, people in various areas, both traditional and non-traditional, combine various methods, a common denominator being AI and deep learning applied to anything from data sets about energy efficient buildings to, you know, searching for drugs, searching for new materials, analyzing cosmology data. So that's the kind of thing that I guess Bridges in a way was born for before they even existed, but now there's certainly an avalanche of these things.
Yeah, this is terrific. Thank you. So just as a reminder, everyone, this will be available as a recording, and we'll put these resources online. So thank you so much, Sergiu, for making this your time available.
Thank you for having me.